Okay, so the following video is going to be on what we went over for meeting 2 and meeting 3. We went over the basics of cloud computing. So let's go ahead and get started. Okay, yeah, so for lab 2, we went over the basics of cloud. And we can ignore some of these because this is recorded after. Yeah, we can ignore some of these. Yeah, so hopefully everyone got their Azure account set up already, set up with Azure for Students, because that's what we're going to be using for the rest of this program. And some of the topics that we'll go over with this presentation, we're going to go over some of the basics of Azure, some of the basics of computation and virtual machines, and then we're going to get hands-on with virtual machines and also infrastructure as code. So let's first go over some of the basics of cloud computing. So in Microsoft Azure, you have an account, and that is the account that you created with your Penn State email. And on each account, you can have multiple subscriptions. Now, it's important to know what a subscription is. Every single time you create one cloud resource, it is created under a subscription. And each subscription has billing information attached to it. So each resource that you create under a subscription, it's going to charge you on that subscription. And this is a model that Azure uses. For other providers like Amazon Web Services, it's accounts. They call them accounts. And I think on GCP, they call them projects. But basically, that's how it's kind of like a namespace, right? You create your resource and it's kind of siloed from other subscriptions. But that's something important to know. And there's also the concept of regions and availability zones. So there's a lot of regions around the world. And if you want to take a look, the slides will also be below this video, but this map is going to show you what Microsoft's global infrastructure looks like. They have data centers all over the world. And if you're building bigger applications, you might take advantage of other regions around the world to make your application closer to people using it in other places. But basically, each region has 2 availability zones. And our closest region is in Virginia. And I think the region is called West US 2, I think. But yeah, if you take a look at this diagram right here, you can see that, okay, so we have the global infrastructure, and then we have different regions. And then within each region, there's at least 2 availability zones, and each AZ is made up of 2 or more data centers. And we won't really worry too much about this. This is only a big deal if you're building large scale infrastructure. But most of the time, we're just going to create our cloud resources in one region, which is probably going to be in Virginia. And here's actually a map of all the resources, services that Azure has. The good thing is across cloud providers, most of the services are very similar. So if you learn Microsoft Azure, you're pretty much good for all of cloud computing. We're going to try to get to as many of these as possible, and hopefully we can get over most of it. So let's look at our first cloud resource, the virtual machine. So what is a virtual machine? Do you have any ideas on what a virtual machine might be? So think of a virtual machine as a siloed environment that you treat as one single computer. It might not be one single, physical hardware computer, but you treat it as one. There might be multiple virtual machines on one physical machine, but each virtual machine has its own networking components, so its own IP address. So you just treat it as like it's one single machine. And taking a look at virtual machines in cloud computing, remember, we're billed on like a pay per hour model, right? So even if you don't use the virtual machine, even if you don't use it for any computational tasks, if you have it rented, they're going to be charging you money. And that's something important to remember, right? We have to make sure that we, at the end of these workshops, we always double check that we don't leave any resources running on our account, because that's gonna drain our account. And these virtual machines are very customizable, and this is true for all cloud providers. You can customize, CPU type, storage amount. Of course, we can choose the location of the virtual machine, and we can also choose the number of virtual machines. And this is the same model for most other cloud providers. So Azure has 3 specific offerings. We're mainly going to focus on Azure virtual machines. The other 2 down here are a little bit very specific. So most of the time we do not have to worry about this at all. So choosing a virtual machine. There are a lot of different optimizations for virtual machines, and each one has even more customization within it. So let's take a quick look, right? This only really matters if you're, a part of a huge project and the cost efficiency is really important. But most of the time, for our small projects, right, we do not really need to worry about these optimizations. So these are the different types of virtual machines. As you can see, we have a general purpose one. This might just be, we could just spin it up for our small projects. And, it has a balance of CPU and memory. We also have one that's optimized for computational purposes. This one has a high ratio of compute to memory. This one might be good for running machine learning tasks, for example, because you need high computational power for that, right? And you don't really need as much for the rest. Okay, and then on the other side, we have one that's optimized in memory. This one has a high ratio of memory to compute. And then that might be for a cache database. We'll learn about Redis, which is a cache database. And then, of course, there's a few more over here. We have one that's for GPU, high performance compute. Actually, HPC, high performance compute, is, I haven't messed around with this as much, but I think it's really important for certain data science analytics scenarios. We can look into those later. So let's walk through our virtual machine creation. So in this re-recorded meeting, we're not going to go over this part. What can we do with a virtual machine? It's basically our own dedicated server or computer. You can run any computational tasks you want. You can download web server software on it and then have it serve a website to whoever visits that IP address. You can run, ML models, of course. The most important thing to remember is that your virtual machine is ephemeral. That means if you destroy that virtual machine, you're going to lose all the data that was on it. That's why we're going to also get to data storage and databases in the future. So there's 3 main ways you can launch cloud resources. If you go onto the website in Azure and you follow the steps to create a virtual machine, that's the website method. That's the slowest method. And that's for introducing cloud, but we're not going to use that in the future. There's 2 other ways. You can also use the command line. Later, we're going to install the Azure CLI, and that is another way you can create resources. But the fastest way and the safest way and the best way that most organizations do it with is using infrastructure as code. And okay, so the infrastructure as code tool that we're going to use is Terraform, which is one of the leading tools for infrastructure as code. And in the future, we're mainly going to be using Terraform to launch cloud resources. If you're exploring a career in cloud engineering, solutions architecting, or cloud infrastructure, this is one of the most important tools that you could possibly learn. So let's go over Terraform real quick. So what does Terraform let us do? You can see here's some Terraform code. So what Terraform lets us do is represent our cloud resources as code. We can easily launch anything from one virtual machine to an entire software system. And so how it works is Terraform is declarative. So what that means is the current state of your code represents the current state of your cloud infrastructure. So let's say your Terraform code has 5 virtual machines defined. Okay, you run that code, you're going to have 5 virtual machines on your cloud account. And now let's say you remove 2 blocks of virtual machines, and now your code only defines 3 virtual machines. If you run that code again, you're not going to have 5 plus 3. You're going to have just 3 virtual machines. So that, remember, it's declarative, because there are some other tools out there like Ansible that are not declarative. Those are like you add on and subtract. So the code you currently have represents the cloud resources that you currently have. And why? Well, first of all, it's really slow to go through the website and create the resource and, like drag down menu. That's not practical for real organizations. And of course, it's also safer, right? We could have everything defined already. We do not have to, because it's automation, right? We do not have to use, it's not prone to human error, right? And one of the best things is it allows for collaboration, right? If you have any experience with GitHub, right? These files could be stored on GitHub and other people could grab that code, Terraform code from GitHub and run the infrastructure on their account, right? It allows for teams to operate. So our Terraform code files are going to be stored in our GitHub repository. And now let's try running a virtual machine with Terraform. So I'm actually going to head over to, okay, I'm not going to head over to VS Code just yet. So first of all, I would really recommend everyone to get VS Code because that's one of the leading text editors. And it's going to help you guys a lot because I'm also going to be using VS Code here. And it'll also help you with, text suggestion, a bunch of cool things. So first of all, before we head over to VS Code, we're going to need to install Terraform and the Azure CLI. So at this point, we've realized that installing Terraform and Azure CLI differs a little bit between Mac and Windows users, and sometimes we have a lot of struggle with this part. So from what we've seen, at least, Terraform and Azure CLI install on Mac really easily. You just install those, and then the Mac OS puts it in the right place. So then when you run it in the terminal, it works. But from what we saw for Windows, the install for Terraform was a little bit complicated. So in the video below, there's also going to be a document on how to install Terraform for Windows users. So both of these are CLI tools, command line tools. That means we use these tools in the command line. So we're going to get to that later. And then, of course, also head over to Nittany Data Labs GitHub, and then go to the NDL Cloud Lab repository. If you download that repository and open it up in VS Code, you now want to CD into the lab2 subdirectory. And that's going to be where we're going to do our work. Let's take a quick look at the code now. So I'm going to head over to VS Code. Let's see. Okay. So I've opened up VS Code. Actually, never mind. Open up, let's see, lab 2 or lab 3. I think these are the same. Let me double check. Okay, so open up lab 3 actually. I'm going to be using the lab 3 code here instead. I will double check if this is still the same as the GitHub repository. So, okay, so let's see. When you first open it up, okay, so when you first open up the project in VS Code, it's going to look like this, right? And then if you head over to, you see this error thing right here, and you press that, that opens up the terminal, and then you can go to the terminal. Okay, so we're now in the command line or the terminal. If you do like an ls, you can see that, okay, we see the 5 elements that we see on the side, right? Now we're going to want to cd into lab 3. Okay, now that we've cd'd into lab 3, you can double check if you're in lab 3, right? You can do another ls, and then you should be able to see one main.tf file and one readme.md. Okay, so now at this point, you might be wondering, okay, did I install Terraform in Azure CLI correctly? We can double check in our terminal, right? If we run Terraform in the terminal, okay, so you see I have it installed. It shows you some help commands right here, some help commands. I'm also gonna run Azure, which is AZ. Okay, so it also shows some help commands right here. So that means I have both tools installed correctly on my machine. If you see some kind of weird error, like, I don't know, let me type something random. Like if you see command not found or something, that means that command, either Terraform or Azure CLI, wasn't installed correctly. So you might want to double check if it's installed correctly. So what we're gonna first do is we're gonna log in to the Azure CLI on this machine, because what we're gonna do with infrastructure as code is we're gonna use our computer to run the infrastructure as code tool, and that's gonna send requests to create cloud resources on our account. But we have to tell Azure that, you know, we are logged in on this machine and that it is really us. We own the account. So we're gonna use AZ login. If you use, okay, I'm going to head over to the other screen so you can see. Okay, so if you do, so you can run AZ login. So at this point, it's going to redirect you to the browser, and then you can log into your account. And then if you head back into VS Code, you're gonna see a response object. And so, okay, so here's the way it works with the student account, which is a little bit weird, and I find it a little bit confusing. So remember how we talked about, okay, we created an account, right? And we said, okay, we have subscriptions and each cloud resource is created under a subscription. But the way the Azure for Student account is set up is there's like 3 different subscriptions. So we're gonna have to specify which subscription we wanna create cloud resources under. And if you take a look in this bottom left corner on the slides, we can use this AZ account set -- subscription is equal to command to set the correct subscription. So if you go back to VS Code, you should be able to see a return object that looks something like this, right? So you might get 3 different return objects, but okay, this object is going to be inside the command line over here when you log in. So if you take a look, right, you want to go find the object that has the name of Azure for Students. That's going to be the subscription we want to use. And then find this ID. It's going to be the 3rd field, I think. So this ID, you're going to want to grab whatever ID that is. I don't want to show my ID because this is kind of semi-private credential info. So you're going to grab this ID, and then you're going to go back to that command that we took a look at, right? That command was this command, the AZ account set -- subscription equals, and then you paste that ID right there. So what that's going to do is it's going to tell Terraform that, okay, when we create resources, we're just going to create it on this Azure for Students subscription, which has our $100 of free credits. Okay, now that we're inside ignore the lab 2, right? We're going to use the lab 3 directory actually. So ignore the lab 2. So inside the lab 2 directory, we're going to take a look at the Terraform workflow. So I'm going to head over to VS Code again. Okay, so with my VS Code, I think, let's see. So actually, I'm also going to create a git ignore file in here. If anyone's familiar with Git, there's this file called the git ignore, which basically lists a bunch of files that you do not want Git to track. And that's going to be really important for us because there's a few files that might contain credentials when Terraform runs, and we do not want to push those secrets to GitHub, right? Especially if you have a public repository. Someone might be able to, dig up your credentials and then maybe access your account, right? That would be horrible. So I'm going to create a git ignore file and grab some of these files that we want to ignore. And then I'm gonna paste it here. Okay, that should be good. Now we are inside the subdirectory. So what I'm gonna do is I'm first gonna run Terraform init. That's gonna be the first step always when we want to use Terraform init. So what this does is it takes a look at what provider we're using, right? We're using Microsoft Azure, and it's gonna grab the necessary code for Terraform to make calls to Microsoft Azure to create the cloud resources. So now that we've initialized, how about let's take a look at what Terraform code we have. So over here, we have one main file. It's called main.tf. .tf is it's the Terraform file name. So, okay, so at the top, we have the provider we described, right? We're using Azure. That's our provider. So that's described at the top. And then now let's go down to the second block. So the syntax of Terraform code is if you want to create a resource, you put resource, and then you do a space, and then you do resource type, right? This is like variable type of thing if you're familiar with programming languages. And then you do another space, and then you do variable name. So, and then you have this bracket, the curly brackets, and then you can describe the fields inside that variable. So this first cloud resource that we're describing is an Azure resource group, and we're naming it example. So what an Azure resource group is, it's like a name tag that you attach to cloud resource that you create in Azure. So for every single resource that you create in Azure, you have to tag it to some resource group, which is why we define it first. And we called it example. And we have two fields inside here. We have the name, which is example resources, and then we also have the location, which is West Europe. So if I were to run the code, it would create the resources in West Europe. You can also use it in any other region you want. So we have this resource here, and now I'm also going to create another resource, an Azure virtual network. And this one is also going to be called example, and the name is going to be example network. And some of these details are more complicated for now. Like if you're a networking engineer, you might know what this is, but this is like, it's more complicated for now. And for the location of this virtual network, we're gonna attach it to the same location as our resource group. So if you're familiar with like object-oriented programming, this is kind of like the same syntax, right? So we say we have an Azure resource group, and then I'm gonna go to the .example. So it's this one, right? And then I want to get the location from this one, right? So this is gonna grab the location from here, which is West Europe, and it's gonna paste to West Europe right here. So now our virtual network is also in the same location as our resource group. This is the same idea over here. And that's this resource. And now looking at the third resource, we have an Azure subnet. I called it example, the name is internal. And then we have the same idea over here. And then this is more complicated for now, but it basically just defines like a list, like a range of IP addresses. Okay. And now we're also looking at the fourth resource. Okay, This one is an Azure Network Interface. This is also a little bit more complicated for now, but as you can see, we have the same idea with like attaching the variables, and this one configures the IP. Now, for the most important part for this Terraform code is the virtual machine, right? That's what we said we're going to create. So the resource is an Azure Windows virtual machine. We're calling it example. As you can see, we're attaching it to the exact same resource group and also the same location, which is West Europe. So this one's going to be a standard F2. If you remember from our earlier in the presentation, we took a look at different customizations for virtual machines. This is like one of the customization sizes for the virtual machine. And over here, we also have the admin username and admin password. Obviously, this is very not secure. So in the real world, don't do something like this. We would probably want to do something that is way more secure than this, right? So this is just an example. Okay, so for network interface IDs, we're also attaching it. So this is going to be, so this is Azure Network Interface, which is this one, right? .example.id. So it's going to grab the ID from, where is it? Yeah, from here. Yeah, it's going to grab it from there. And then that's going to be our network interface ID for our virtual machine. There's some more configurations within this virtual machine. So a lot of this stuff actually is, optional, but, you could just define way more or way less, depending on, what you're trying to do. But over here, we defined the OS disk. We say, okay, this is it's going to have read-write caching. And then, okay, so this is also one of the most important parts. This is the source image reference. So with the virtual machines, how they work is we have a virtual machine image, and think of a virtual machine image as a blueprint. And whenever you want to create a virtual machine, it takes a look at that image, and then it creates the same virtual machine from that image every single time. And that's also how it works for cloud computing. You can define an image, and then it's going to take a look at that image and then create that same virtual machine every single time. Obviously, it has to create the same thing every single time. Otherwise, it would not be reliable. So that's what Terraform code looks like. Everything is pretty clear, and you do not have to do too much manual stuff, which is why it's not prone to human error. So now let's go ahead and create the rest of the Terraform workflow. So we already did Terraform init, right? So that grabbed the necessary code for us to create cloud resources. So the second step in the Terraform workflow is Terraform plan. So what this does is it scans through our Terraform code, and it tells us, okay, if you were to run Terraform apply, which is the next step, this is what your code is going to create. So this is kind of like a safe layer before you create the stuff, right? It's going to warn you, okay, as you can see here, it says, okay, your code is going to create 5 resources, right? We have 5 resources here, and it's going to change 0 and destroy 0. That's because I have nothing on my subscription. Now that we've done this, I'm going to go ahead and create the resources. The third step in the Terraform workflow is Terraform apply. And now this is actually going to create the resources on your subscription. Okay, so this is taking a little bit of time, I think. Okay, so it's going to add 5 resources, and I'm going to say, yes, I want to create 5 resources. So right now what we're doing is we're using our computer kind of as like a client, and we're reaching out to the Azure APIs, and we're telling them that we want to create resources on our account. But maybe if you're a developer, right, and if you're familiar with GitHub, right, if you're familiar with GitHub and GitHub branches, another thing you could do with Terraform is you can attach Terraform to a GitHub action. And what that would do is, let's say you make a push to GitHub, you can have the Terraform process be attached to a GitHub action. So then whenever you make a push to your GitHub branch, it's basically gonna, the GitHub action is going to go ahead and run all of the Terraform code and do some double checks, right, before that code goes through. Okay, so this is maybe that's a bit more complicated for now, but the point is that we're just using our computer as the client to run the Terraform scripts to generate the cloud resources. It doesn't have to be our computer. It could also be another virtual machine out there or another computer. Yeah, so that's the way Terraform works. The resources can be created from any authenticated client. And in our case, it's going to be our computer. Yeah, and then the reason we have a .gig nor file here is since this project is using Git to track files, the dangerous thing is we do not want files with credentials to be published, right? Some of these files that I will not click on have private credentials. I think Terraform state, the .tf state might have credentials. That's why all of this is being tracked here so it doesn't get pushed. And then the .terraform contains the code, the actual logic for Terraform to make calls. And okay, look, we created 5 resources, right? So that was the Terraform apply command. And if you want to head over to your Azure website and you take a look, you'll actually see a virtual machine is running there. And we did that from VS Code. Okay, and then now the last step in the Terraform workflow is Terraform destroy. What this does is it's just going to destroy all of the resources that we just created. And that's pretty much it, right? There's only 4 steps to the workflow: Terraform init, Terraform plan, Terraform apply, and then Terraform destroy. I like to think of the acronym IPAD, right? Init, plan, apply, destroy. And that's pretty much it. So in the future, this is going to be a fast way for us to spin up cloud resources. So then we don't have to, take manual steps. So I'm going to say, yes, I do want to destroy all of these resources. Okay, so while that's destroying, let's head over to the presentation again. Let's take a look. Yeah, so we went over some of this stuff already. Yeah, that's pretty much it, actually. That was what we did for meeting 2 and meeting 3. So if you have all of that down and all of those concepts down, you're pretty much all set. So yeah, you definitely want to make sure that all of the resources are destroyed, because if you don't destroy them, it's going to be rented and it's going to charge you money. And we do not want to waste our $100 in credits. And like, if this were like the real world, right? And you're dealing with like a huge scale, like let's say you're like one of the lead cloud infrastructure architects at a company, right? And you're not careful, right? You could be burning through some money. But of course, we also have, we can also set budgets, right? That's something we might get to, like cost management, some of these things in cloud computing that are important. think it's still taking some time. Okay, so another thing is we're going to be getting the foundations Azure certification, but if you really do want to get into cloud computing and you think this is really interesting, the most important cloud certification that you can get is going to be the Amazon Web Services Solutions Architect certification. And if you have any questions and you really want to get deeper into cloud computing, you can come ask any of the NDL officers, Ray or Dan, and we'd be interested to help you guys. So I do not know why it's still destroying the resources, but it's pretty much done. Okay, now, okay, look, nice. We have all 5 resources destroyed. And yeah, now you have a handle on the basics of cloud computing, virtual machines, and also Terraform. And that was meetings 1, 2, and 3. I'll see everyone at meeting 4, hopefully.